Hello everyone, I'm Sahas Jayasinghe. So this is first presentation of information and communication technology in my assignments. So let's start this. This is the content of my presentation. So let's move on to first one. First one is identification of internal components of a CPU. Identify the internal parts of CPU. First one is control unit, second one is microprocessor, third one is instruction register, fourth one is clock, fifth one is arithmetic logic unit. First we are going to talk about arithmetic logic unit. In this, the function is it's responsible for executing all arithmetic and logical operations inside the CPU. Arithmetic operations are including addition, subtraction, multiplication and division. Logical operations includes and or not so operations, typically used for comparison and decision making tasks. Second one, clock. The function of clock is the clock all compressions within the CPU. This forms a constant timely generated signals that controls the running of instructions. The clock speed is measured in gigahertz, and in some simple terms, this is describes how many instructions the CPU can process per second. The third one is function of a CPU. Function of a CPU is first one is fetch, second one is decode, third one is execute, fourth one is cycle store. This pic in this slide that shows how it works together. First one is fetch. Let's talk about fetch. Fetch is instructions are fetched from system memory. Instruction from a part of a program which is stored in the form of binary data in memory locations. Examples for fetch: the CPU fetches instructions like add two numbers that is stored in RAM. The second one is decode. Translation of fetch instruction is the main purpose of this. The CPU splits the instructions into signals that the CPU can understand. Examples for decode: the instructions add two numbers is decoded into operations like retrieve values of from registers A and B. Third one is execute. Execute all instructions using ALU. Maybe arithmetic, a logical comparison, or a data transfer. Example for execute: the ALU performs the addition of the two numbers and saves the results. The cycle store: the operations results is stored. Results may be stored on the registers as temporary results or written back to the memory for long-term storage. The sum taken from the two addition is then stored in a register or RAM for later use. In this let's gonna discuss about how computer hardware components work together. A computer can be described as a very complex device that comprises of hardware parts through which it processes, stores and transmits information. All of them have its purposes and their relationships is controlled for functioning of the computer. Now a closer look at how these different parts work together will be provided. First one in here is an overview of their interactions. First one is input devices, second one is central processing unit, and third one memory, it's RAM, fourth one storage devices, fifth one output devices, sixth one motherboard, and seventh one is the power supply or PSU. First one is input devices. The roll call is input devices allow users to interact with the computer by providing data and commands. Examples for input devices are keyboard, mouse, scanner and microphones. How it interacts: send user input to the CPU via system buses for processing. Example for input devices, how it works: typing a word on a keyboard sends signals to the CPU for interpretation. Second one is central processing unit. The main role is central processing unit processes instructions and manages data flows between components. How it interacts: fetches instructions and data from memory, processes the data using the ALU, sends results to the output devices or storage. Examples for that: the CPU calculates numbers typed into a spreadsheet and updates the display. Next one is RAM. The main role is RAM is provides temporary holding space for data and instructions. The CPU, in how it interacts, holds active programs and current files in use, interacts with the CPU to access data quickly. For example, these: while editing a document, RAM holds that file until it's saved or the computer is shut down. Let's gonna talk about the let's gonna discuss about storage devices and different types of storage media and the use of each with reference to the purpose. Storage media are devices or materials used to store digital data. They differ in speed, capacity, price, and where they can applied. The main types of storage media and their applications is highlighted below. These are some examples for storage devices, and let's move on to the next one and talk about each other. First one is hard disk drives. In short form, we are calling that HDD. Some description about that: it's showing us store data on magnetic platters. Data is written by a mechanical arm. Characteristics of hard disk: save high capacity up to several terabytes. Second one is slower compared to solid state drives. Third one is relatively cheap per GB. Applications that would can be applied to these to in the desktop PCs, laptops, and servers. Best suited for large file storage such as video backups and archives. So the next one is solid state drives, SSD in short forms. There is also the same small description about that. Uses flash memory with no moving parts, faster than HDDs. There are also characteristics of solid state drives: high speed of writing and reading. The second one is more expensive per GB compared to HDDs, reliable and durable. Users, how we can use that: the operating system is usually installed on it. Applications that require high speed data access such as gaming, video editing. Optical disc. Examples for these optical discs are CDs, DVDs, and Blu-rays. There are also small descriptions about optical disc. Stores data using laser etched bits on a disc surface. There are also characteristics of optical discs: portable and inexpensive, limited storage capacity up to 128 GB for Blu-rays, lower access speed. Users of these media distribution: movies, game, music, archiving, and backups, like that. In next one, we're gonna discuss about how data is represented in computer systems. How data is represented in computer systems. In computer systems, the data is represented using binary, which is system based on two symbols, zeros and ones. It grants the computers the ability to process, store, and communicate information with efficiency using electronic signals. The detailed explanation for various data representation is as follows. First one is binary representation of numbers, representation of text, images, sounds, and instructions. First one is binary representation. Computers use electrical signals and have two conditions. On is 1 and the off is 0. Any data is represented as a stream of zeros and ones known as bits, short for binary digits. Examples: one bit can represent two states, zeros or 1. 8 bits, 1 byte could represent 250 states from 8 zeros to 8 ones. Representation of numbers. First one is integers. Numbers are represented binary using positional notations. Example: the decimal number 13 is represented as 1101 in binary. Negative numbers. Negative numbers are usually represented in two complement forms. Example: 1, 3, and as an 8-bit 2's complement is 11110011. The seat one, floating point numbers. These are used for decimal and very big small numbers. It is represented using scientific notation, binary, matrica, and exponent. Example: 5.25 will be stored as 2 ones and 6 zeros, 1 0, 1 0, 1, and some kind of zeros in IEEE 745 format. Representation of text. ASCII, American Standard Code for Information Interchange. Every character is given binary codes of 7 or 8 bits. Example: the letter A is 651065. Unicode. ASCII is therefore extend all cover and all characters of many languages and symbols. The one of that are encoded are schemes UTF-8, UTF-16 or UTF-32. Example: the symbol euro is in UTF-8. Representing images. Bitmaps. First one is bitmaps. Raster graphics we are calling about solos. An images is a matrix of picture elements, pixels, where each is quantified as a set of binary numbers. Color representation. Grayscale, the brightness values of the background and all images is represented by a byte ranging from black zeros and white 255. RGB model uses 3 bytes per pixel with red, green, blue. Example: a pure red pixel. I have showed the code of that. Next one is how encryption can be used to represent data. Encryption is the process of transforming and the plain text to readable information, plain text to an unusable or not easily understandable format called text by the use of an algorithm, and we can access code known as key. In simpler words, encryption is quite useful is ensuring the data is not altered, and moreover it can be protected by the trustworthiness of the system is in storing and transmitting the data from one point to another. However, information encryptions can be also regarded as a way of emulation, a communication language that only certain users can read. Next one is how this is encryption is used to represent data. First one is encryption basics. The second step is types of encryptions. The third one is how encryptions represents data. Fourth one is examples of encryption representing text. Fifth one is practical uses of encryption for data representation. Encryption basics. Plain text. The readable original data, for example, a message or a file. Clip text. The encrypted version of a plain text which looks like a random set of characters and it's not clear without decryption. Encryption algorithm. It is a mathematical function that specifies the way data will be changed. key, the piece of information used by the algorithm to change plain text into hypertext, which is what users' security depends main only the strength of and the security of that key. This chart shows the types of encryption. Encryption styles are there are two types: symmetrical and encryption. For description for that, only one key is used for encryption. Key usages a common secret key for both sides. Example AES, DES. Asymmetric encryption. Description for that two key systems that consist public key used to encrypt and a private key used to decrypt. Key usages public and private keys. Examples RSA, ECC. How encryption represents data. Data transmission symmetrical data transmissions. First one is symmetric encryption. The simplest basic case will act as an encrypted algorithm by encryption by single key. This allows encryptions then only by the same key. Next one is asymmetric encryption. Encryption is performed using the recipient's public key, and it can be decrypted only with the recipient's private key. Should the examples also apply in this case to secure communication wherein the public key encrypts the data but only the private key can decrypt it? Data integrity and authentications. The further use of hashing in conjunctions with encryption, such as digital signatures, allow for characterizations in a way that guarantees integrity and authenticity of the data. Digital signature. The hash of the data is encrypted via private key, which may later be verified by a counterpart using the public key. This is useful for denying tampering at that. How images and sounds are represented in computer systems. In computer systems, everything including images and sounds is ultimately characterized by binary digits called bits represented as a form of zeros and ones. This is because the computers performs their work using the binary systems. The representation of images as well as sound has been designed in such a way that taps into visual and auditory information to allow efficient storage, processing, and transmission. How images and sounds are represented. First one is representing images in computer system. Second one is representing sound in a computer system. Third one is compression of images and sounds. Representing images in computer systems. In the most general sense, images could be generally divided into raster and vector graphics. Each one of these depends on different means of encoding visual information. Raster graphics comprise pictures in AX. Raster graphics comprise pictures in a XY grid built out of pixels or picture elements. Pixels are assigned a color and these collectively create the whole image. Next one is resolution. The number of pixels along the horizontal and vertical axis of an image. Its dimensions characterized by height and width. Color depth. It defines how many bits go into the describing of one's pixels of color. Well-known forms include 8-bit color depth, 8-bit color depth, or 250 colors. 24-bit color, 16.7 million choices. 32-bit color depth has added an 8 bits for transparency. There are few examples for all this in this slide. Vector graphics. Vector graphics represents images based on a mathematical equation and geometric shapes, such as lines, curves, and polygons. They are not pixel based, unlike the raster graphics. Scalability. Vector graphics can be scaled up or down in size without any quality losses because they reliability. Scalability. Vector graphics can be scaled up or down in size without any quality loss because they rely on mathematical formulas. Common file formats includes SVG, EPS, and PDFs. There are a few examples also for that. Representing sound in a computer system. Digital audio represents in sounds all digital forms. In it consists of converting continuous waves from corresponding to analog sounds into discrete data that computer can process. The most important feature in the representation of sound digitally is sampling. In first point, the sound signal is sampled at regular intervals. In the broadest sense, the sampling rate is the number of samples taken per second, usually expressed in hertz, and typical sampling rates are as follows. There are some examples for sampling, and next one is bit depth. A term often associated with sampling, bit depth refers to the number of bits used in representation of an individual sample. 8-bit audio has 256 levels of possible amplitude. The channels. Mono sound is sound with one channel. Stereo sound is with two channels. Surrounded sounds with multiple channels. Types of audio file formats. VAV is uncompressed. VAV is an uncompressed audio format with often wider use in making audio recordings. MP3 compressed audio format to reduce file size of the audio signals with acceptable quality, which means a lossy compression format. FLAC is lossless audio comprehension formats which compression of images and sounds. Images and sounds are both candidates for compressions and serve their goals and reduce file size, use file size easy for storage and transmissions. Image compression. Lossless compression. Such formats optimize space without altering original sound data PNG, TIFF. Lossy compression. Such formats lost some data, but lost data is often imperceptible human sense in exchange for simultaneous and massive reduction of file size. JPEG for an example. Audio compression. Lossless compression preserves every unit of the original audio information. Lossy compression. Unlike lossless compression, its job is to pan of data is scientifically and there are also loss compression also, and there is a description and examples also. Summary. Data type, images, raster graphics and vector graphics, sounds, sampling and bit depth. There are some examples and representation method also that we discussed before. Logic gates and their purposes. Logic gates are the basic building blocks in the digital systems which performs different operations and Boolean algebra. Each gate always accepts one or two binary digits, 1 or 0, but produces a unique results based on one logical operation. First one is AND gate. AND gate symbol is purple square. Truth table. When we create in the truth table, inputs are A and B, output is A plus B. Okay, the symbol is green square. Inputs are A and B. In OGate, its symbol is green square. Inputs are A and B. The intro table output shows as A plus B. NOT gate black square. Input A, output is A dash. NAND gate orange square. Inputs A and B. Outputs are A dot B dash. NOR gate inputs the symbol shows a blue square. Inputs A and B. Outputs A plus B. XOR gate orange square. Inputs A and B. Outputs A B. Applications of logic gates and gates used in digital circuits to activate an output only when all conditions are met. OR gate common in systems and requiring at least one condition or read output. NOT gate. In NOT gate used to invert signals such as toggling between on and off states. NAND and NOR gates fundamentals for building more complex logic gates used in memory and processors. XOR gate often used in parity checkers and error detection systems. XNOR gate used in equality comparison circuits and error correction. Different types of computer networks and their purposes. PAN, personal area network, and I have showed some of these, and let's talk about one by one. Personal area network, we call it simply as PAN. A low-range network that connects certain devices, example smartphones, tablets, and smartwatches within very short distance, typically by the means of a Bluetooth or USB connections. The main function is synchronization of devices, transfer of files and communications. Second one is local area network LAN, a network contained within the confines of a small area such as an office, home or school. The medium, whether Ethernet cables, Wi-Fi provides connectivity. Third one is wide area network WAN, a network of high scale that covers large geographical areas and can interconnect many LANs through the telecommunication. The largest WAN is considered to be the internet. Helps enable communication and sharing resources from one location to another location, sites, countries, or even the continents. Metropolitan area network MAN, a network that is bigger and larger than a LAN but smaller than the WAN. Usually extends coverage the area of city or area of a campus. High-level connectivity to organization and the users of different peoples residing in a metropolitan area. This network is commonly used by the governments or universities. Hardware, software, and transmission media used in computer networks. Hardware in computer networks, software in computer networks, transmission in media in computer networks. We are talking in this. Hardware of computer systems. NIC, routers, switches, modems, access points, cable and connectors, servers, firewalls are the examples for this. Software in computer networks. Operating systems, OS, network management softwares, firewall softwares, antivirus and security softwares, protocols, virtual private networks softwares are the examples for that. Transmission media in computer networks. Wire transmission media, examples twisted pair cables, coaxial cables, fiber optic cables. Wireless transmission, radio waves, microwaves, infrared, cellular networks. The range of World Wide Web technologies. A range of World Wide Web technologies to provide wide-ranging service and experience over the web. The World Wide Web depends on diverse technologies aids. Such technologies allow for the making, transmission and interaction of web applications and websites. There are some task of that. First one is web development technologies. HTML is also known as hypertext markup language. The second one is CSS, known as cascading style sheets. Third one is JavaScript. Fourth one is framework and libraries. We can divide them into two: front-end frameworks, back-end, front-end frameworks, and back-end networks. Web protocols: HTTP, HTTPS. This first one, protocols for transfer of information over the web of networks, where the direct internet connection has added protection against unauthorized use of information transfer. FTP. This is most commonly used for in the process of transferring files between the client and the server. REST and SOAP. The web services protocols aim to facilitate communication between distributed applications. Server-side technologies, web servers, web application stacks that provides users with web content like Apache, Nginx, and Microsoft IIS. Database, relation database system that stores and manages data for web applications, MySQL, MongoDB, and PostgreSQL. Programming languages on the server side. This involves programming languages like PHP, Python, Ruby, and Java. Client-side technologies. Web browser. This is refers to desktop software like Chrome, Firefox, Safari, or Edge that users can use on the web computers getting access to the web. Web APIs allow web application to interact with other entities. Different type of computer network topologies and their purposes. Network topology is more than physical logical layout of devices that their connections in the network. Each topology is designed for certain performance, scalability, and availability requirements. There are some network topologies. First one is choosing the right topology. How we can choose the right topology. First one is bus topology for small and cost sensitive networks. Second one is star topology for more recent LAN with single points of control. Third one is ring topology used for node with where the data will flow and it should be continuous. Fourth one is mesh topology used for mission critical systems that need to be extremely dependable. Tree topology. This is ideal topology for large hierarchical networks such as those used by corporations. Hybrid topology. For network specific needs highly scalable networks. Number 2. This is April 3rd. It is Wednesday. First one is bus topology. Description about that, it's more one central cable, the bus is shared by all devices. Purpose used in small uncomplicated networks where low cost and simplicity of installation are higher priorities. Advantages: it is easy to set up, requires minimal cabling. Second one is star topology. Here's all devices connected to the central hub. Purpose of this is typically modern LANs is more centralized management and control. Advantages of these: new devices can easily be added and removed, disrupting the network. If one device fails, the others are unaffected. Disadvantages: single point of failure, hub switch has more cabling than bus topology. Third one is ring topology. Description for that: connected a ring where each device is connected to two other devices. Purpose: can be used networks where predictable data flows is essential. Advantages: since data passes only in one way, collisions are less likely. must be suitable for bigger data loads. Thank you for thank you.